Evaluation for large language models is fundamentally broken. This is a big problem in the field, especially with LLMs. We use a bunch of benchmarks to evaluate performance of these models. These benchmarks in many cases are supposed to be about language understanding, but they don't really test reasoning. They don't test the things we typically associate with intelligence. Let's start with me holding a ball here, I'm going to drop it, what's going to happen? Now, if you ask a large language model that question, the model is per se probably not going to reason about the fact that the ball would fall because of gravity. What would happen is it would probably retrieve information from the internet. Someone on Reddit or Wikipedia, whatever it was, wrote about balls falling when dropped. That is semantic retrieval, right? It's retrieval of information in the form of language, but is it really reasoning step by step about the world?
Hey guys, welcome to another episode of the CTO Show by Tech Vibe. Today we have a very special guest flying from the United States, who is Jacob. And then Jacob is currently a researcher at Facebook AI Research, or FAIR, and he's also a adjunct faculty at the University of Pennsylvania in computer science. So thank you so much for your time and welcome to the show, Jacob.
Thanks for having me, Philip.
I guess, Jacob, I'm so curious actually about one thing. You know, you're normally based in the US, you work for Facebook AI Research. Why are you in Vietnam in the first place? What brings you here?
So I came to Vietnam for the first time at the end of last year, and I've been back 3 times since.
Wow.
And I expected to spend a week here, and I ended up spending a month my first time here. I love Vietnam. I love the energy here. I love that there are real builders here. There are people who are hungry here. And it's electric, and it's just really wonderful to feel that optimism that's here in Saigon and other places in Vietnam, of course, as well. But I have an amazing network, of course. Now I have friends who I adore, person I love in Vietnam. I have all this stuff that's just grounding me here, and I'm lucky to be able to go back and forth.
That's incredible. I mean, we hope you stay. Awesome. Well, Jacob, I love your background, and I think it's so rare that we have someone as specialized as you in the field of AI research with us here in Vietnam. And so what I want to do is I want to start with probably the toughest question, right, that everyone speculates, which is AGI coming, and if so, when?
So my answer to this question is going to frustrate some people. I think AGI is a bit nuanced as a concept. It's not the general intelligence we think it is. And the reason is that human intelligence is fundamentally specialized. If we think about the system that we would build that's intelligent, it's going to be in the image of human intelligence. I don't know if humans even know what general intelligence is because, again, our notion of intelligence is defined by the way we think and reason. And so what we're going to build in the next several years, decades, are systems that are intelligent, but they're superhuman. And so I don't know if AGI is coming per se, but we are going to build intelligent systems that are better than humans at various tasks we already have in a lot of domains, like speech and vision and language. And those are exciting developments. But in terms of general intelligence, I don't know if we're going to get there.
Can you extrapolate a little bit more about what general intelligence means in kind of these days? Because I guess the traditional test for whether or not a computer was intelligent was the Turing test, right? And that's more around if a computer can pass this like conversational standard. And I think if you look at any of these LLMs these days, like that seems like a relatively low standard for a lot of humans, right? So What is general intelligence? What does that benchmark look like now?
So general intelligence is a very hard thing to define, which is part of the idea that the intelligent systems we'll build are human, in that the Turing test is about whether or not a human can distinguish an intelligent system. And that's a fundamentally human question, right? It's a question of the way humans reason. It's a question of how humans perceive the world, how humans process information, and how they work through problems. And so that still is human. Even the benchmark that we thought was for AGI is still fundamentally human. And for that reason, again, I don't know that there's a general definition for AGI that is outside of the scope of what humans believe to be intelligent. Now, we can think about this from the perspective of axioms, right? We can start to build notions of reasoning symbolically. We can use math to create all of these inductive systems, and we can do that. that math is also in the image of humans, right? We build mathematical foundations, logical foundations for what we do in the sciences. We do that with human bias. And that's not to say there aren't entirely other systems that we could have developed if human intelligence were different. So in that sense, I don't know if it's possible for humans to define general intelligence, because there's always going to be bias. There's always going to be a worldview. There's always going to be a path to arriving at even the foundational elements of that definition that is coming from the things that make us human.
Wow. Okay, this is very philosophical. I guess, like, when a lot of these LLM companies or Facebook or some of these AI labs do talk about AGI,
Right.
Is there a benchmark or standard that they commonly refer to? Given that this definition is still a little bit blurry or
Right. This is a big problem in the field, especially with LLMs. Evaluation for large language models is fundamentally broken. We use a bunch of benchmarks to evaluate performance of these models.
Right.
These benchmarks, in many cases, are supposed to be about language understanding, but they don't really test reasoning. They don't test the things we typically associate with intelligence. And we're developing new benchmarks over time that are slowly able to start to probe those things. But these are difficult questions. The ability to, say, respond to a question is as much about information retrieval as it is about reasoning.
Right.
And so these are different concerns, and disentangling them with benchmarks is very difficult. So to test something in isolation is challenging. And as I said, the field is making progress here. But this is a research question, just like modeling is a research question. What does it mean to build an evaluation benchmark that properly measures reasoning? If I were to ask you if a system reasoned, what might you say? You might say, let's start with me holding a ball here. I'm going to drop it. What's going to happen? Now, if you ask a large language model that question, the model is per se probably not going to reason about the fact that the ball would fall because of gravity. What would happen is it would probably retrieve information from the internet. Someone on Reddit or Wikipedia, whatever it was, wrote about balls falling when dropped. And that is semantic retrieval, right? It's retrieval of information in the form of language. But is it really reasoning step by step about the world? And that's a fundamental difference. And testing that is tough, because the only medium by which you and I can perceive what AI, what we put into it and what comes out of it, is language. And so fundamentally, we have to collapse down to these modes that humans can interpret in order to test these models. And that's another difficulty. So in order to really understand whether or not we have world models inside these large models, we need to continue to do research on evaluation.
Got it. And if it's not language, where we have this human bias in evaluating whether or not it's reasoning or not, what else? What other benchmarks would we be able to?
Yeah, it's
do?
a great question.
Yeah.
So there are benchmarks that are symbolic, right? We now have models that are specialized at doing proofs in mathematics, for instance. There's been good work from a lot of labs around in this area in the last several years. So this is exciting because in theory, I can come up with new problems in mathematics for which there is no text anywhere. There is no even proof form that the model was trained on. And this really tests the idea of generalization, that I'm able to reason and solve problems that I've never seen before as a model.
Right.
And those are interesting settings because there's less ambiguity with language, right? In a formal system like proofs, programming languages and coding is another area where there's a lot of formalism. And so with these, we can more directly test some of the capabilities we're interested in, instead of using language, which is much more inexact and semantically ambiguous and can be retrieved and under the facade of doing reasoning.
Interesting. I'm just curious, when we talk about, how humans actually reason, and obviously I'm not an expert in neuroscience, but fundamentally, aren't people also using probabilistic models in their mind to retrieve certain amounts of information to do, and there's certain logic or certain rules that we have when we think about different types of problems? Is that fundamentally different from the way that, these AI models are working?
Another great question.
Yeah.
Ultimately, I'm not a neuroscientist either,
Yeah.
but ultimately we have some idea of the way we reason.
Right.
We know that it's structured, right? If I ask you what was the state in which Barack Obama was born, is a question. What's the capital of the state, let's say, in which Barack Obama was born? You first have to understand that Barack Obama was born in Hawaii and that Honolulu is the capital of Hawaii.
Sure.
and that there are two distinct steps. So there is structure in that very basic question. And right now, we don't have models that at least explicitly model that structure. And so reasoning right now is happening in a very loose way inside these models, and there might be structure imposed. We have some evidence of that. But ultimately, it's a structured process, and that's one characteristic about it. We know that reasoning involves information about the world, right? We have to perceive things. We have to have inputs from external sources. And we also know that we do make probabilistic predictions about the world. Ultimately, the way that humans experience the world and the way we act and get feedback from the world is probabilistic. When we have a hot pot on the stove and we touch it, we expect to need to recoil just as much as we perceive that.
Exactly.
So absolutely, it's probabilistic. And we need to build models that reflect all of those things, not just the probabilistic part, but the structure and the idea that we retrieve. So all of this should come together, in my opinion, in a model that reasons, that truly reasons.
Got it. Okay. Do you think we're close to doing that, or do we still need to be a little bit more precise about definitions before we can even kind of attack that problem?
I think we have enough precision in definitions to begin looking at this.
Okay.
The challenge is that, well, the field is very excited about large language models, as is everybody.
Yeah.
And this is awesome, and there are incredible product applications, amazing companies to be built, industries to be changed by these models. But sometimes they're a bit distracting from some of the fundamental questions about, do they reason? How can we build models that reason? And we've done a lot of things which augment large language models to make them have reasoning-like capabilities. One example would be to do what we call the agentic workflow, where we sort of add these wires between the models, and we have a loop of models, and they give feedback to one another. And now there's there's some discreteness to the components, and they all combine to produce some interesting output. And like those systems impose structure, in the same way that we do reasoning, there's some promise there, and that's a direction. My belief ultimately is that we need to be doing research that changes the recipe a bit. Large language models are awesome. They scale incredibly well with the amount of data we put into them. They ultimately are relatively simple to train. It's sort of plug and play.
Sure.
There's a lot of details, but
Yeah.
ultimately the way we've created the deep learning recipe is incredibly easy. And so we have to now build models that are a bit more explicit about reasoning and structure in their internals. And that means that we have to reinvent some of these algorithms, is my opinion. So that's what I'm hoping to do over the next few years.
Wow, that's super interesting. And I guess, is that what you're primarily focused on right now at FAIR? And
Yeah, that's one of the directions we're going at FAIR. That my colleagues have published several results about this recently, where we've talked about ways to learn representations of the world that are more agnostic, and then can we really think about search over those representations as a reasoning process, and do that a bit more explicitly and not rely on a big black box model to do this, and in the process impose some of the structural things we think need to be true about reasoning in order to make these models better. So that's the hope.
you mentioned that, there's a world whereby there's these like big generalized models, which you call, I'm guessing, like world models, right? And then there's some of these more smaller models, which are more specialized tasks. Where do you see research evolving, or where do you see the world, headed? Like, is there going to be a kind of a massive model that handles every single case, or do you see more specialized use cases over time?
It's a good question. The trend has very much been that we're consolidating into bigger and bigger models, right? This is the foundation model era, people are saying. And it's true that big models are better. What we have some limited evidence on, and it's proving to be generally true, is that when I have a model do more tasks across, say, modalities, the model gets better. We've known for a long time, say, within a modality like language, that when I do multitask learning, when I have a model learn to do many things at once, this improves its capabilities. Yeah. Now, the question is, if I then learn from images and text and audio, can I build better representations of the world and learn better? And the answer to this question seems also to be yes. And this would intuitively make sense, right? In order to build a world model, I need to at least have inputs from all of the sensory devices that humans have in order to paint the fullest picture possible of what a model is experiencing and what it will reason about. If I hear the sound of a cat and see the shadow of a cat, then the idea of a cat is very prescient, of course. And I want to relate all of these sensory inputs and be able to reason about them simultaneously.
So I guess, does that mean that fundamentally you need to build input devices that mirror exactly how humans perceive and interact with the world? Or are there other ways of being able to develop this kind of input?
So we have devices which are good enough for now, in that we have microphones, we have cameras, and we have ways in computers to reason about this data that have been around for a long time. And those standards have powered deep learning and deep neural networks for learning on these modalities for many years. And those are great, and we're not going to do anything with those per se. There are other sensory inputs, of course, that we don't have, smell being one of them. Being able to do spectroscopy on the air would be very cool, and then be able to model that explicitly and integrate that with other inputs. But another thing, of course, that's emerging is this tactile idea. Right? I have the entire field of robotics, and we're only at the beginning of building foundation models for robotics, building models that can actuate themselves properly. Right. So if I'm holding a banana versus holding this glass, I want to be able to temper the amount of force I apply differently so as to not crush the banana and to not drop the glass.
Right.
So all of these things are very adaptive fundamentally, and I want a foundation model which ideally learns representations of manipulation and of sensory input. And if we have those, then this becomes much more viable. But we're not quite there. There's some exciting research in this direction. There's models that are improving. But a really general foundation model for robotics applications is still something that the field needs to figure out the right recipe for.
And is that because of the lack of training data? Because it's more tactile versus maybe you can scrape the entire internet and all of these archives for more text-based LLMs?
Exactly that. Data is a big problem in that if I want to collect data about robotic manipulation of things in the world, well, I need to have a lot of robots manipulating things and then record them.
Of course.
And, well, I can build farms. I can build arm farms, as they call them.
Yeah.
And I can just manipulate stuff all day and gather data. And that works. And I can build better data sets. And it turns out, of course, because deep learning is amazing again, we have this relationship between the amount of data I put into the model and the quality of the model. And that's phenomenal. And we can do that. Another problem, though, is the density of sensory information is very high. Consider 10 seconds of me speaking. Consider the words that I say. I can represent those words with very little information. It's a few bytes, right? Just a byte per character. And now let's consider the audio of my speaking for 10 seconds. That's a lot denser. There's a continuous signal, there's a waveform, there's many more samples, so the audio is a bit denser. Now consider, say, the video of me speaking for 10 seconds. Now I've added this spatial dimension, there's temporal dimension as before, there's color, there's all this stuff happening. And sensory dimensions for robotics are also very complex. They're very dense because there's all sorts of feedback that I get when I grip something, right? I have all these nerves in my hand. And so modeling that explicitly from all of the input sensors in a robotic device that's good is also intensive. It's dense. It requires a lot of storage. There's very difficult engineering challenges to make that happen. So it's as much about the amount of data, as you say, as it is about the density of that data and the engineering hurdles involved in making it work.
Very interesting. Do you think that we're at a point whereby we have the necessary, compute or GPUs or energy or storage to actually be able to process that information, train these models? Because it does seem like robotics and the real world application of robotics and AI is one of these things that just hasn't really been done in this AI hype cycle. So I'm just wondering, what that major bottleneck would be and when that would actually come. Yeah.
Yeah, and you're right that we haven't seen the expectation come to fruition that there are robots helping us with daily tasks like everyone thought we would.
Yeah.
And one part of that is data, that it is challenging to build all the infrastructure to collect this. There are well-endowed research organizations around the world that have these capabilities.
Sure.
It's still a slow process to iterate. Just because we can do it doesn't mean it's quick. And the other challenge is that there's a lot of research ambiguity. It took many, many years to go from neural networks to neural networks that can learn from speech efficiently and do that end to end. But in the case of robotics, I think, again, the recipe isn't quite there. We have a lot of unanswered questions about the right way to structure a model, how to parameterize this data. I have to convert it into a form that I can input to a neural network. And that's a bit ambiguous too, because there's spatial and temporal and all of these other dimensions to this data that differ a bit from the classical data, images, speech, text that we're used to putting into neural networks.
Very interesting, very interesting. I guess, are there other really interesting or kind of innovative areas of research that you want to share about that you guys are working on?
There's a few different areas that I'm excited about from the lab recently. One is improved models for image segmentation. So this is taking an image, putting bounding boxes around objects in that image, which is a task that we've been able to do with neural networks for a long time. But until recently, we didn't really have the ability to do that efficiently and do that with low latency, which meant we couldn't do it for videos. It was hard, it was very computationally expensive, and now we can, which gives us capabilities like we can follow an object in a video very, very accurately. We can identify the position at any frame. So that's an exciting area that we're building more efficient models that are very high quality and generalize very well to do that. Another is we have some exciting work happening in code. We have a lot of work happening with reinforcement learning with feedback from executing code. So this is an exciting sort of setup for world modeling where I can interact with the world by taking code, running it, and then getting feedback. And it's sort of a toy world. It's a smaller world in which I don't need to know everything. There's a lot of degrees of freedom in this real world we're sitting in, this physical world. With code, it's a bit more constrained. And so it's easy to study, and we can do a lot of very exciting things starting from this constrained environment. And that opens a lot of doors for us. So code is exciting. We have a lot of great systems work coming out of FAIR as well. We have work around faster ways to get transformer decoders to output tokens by skipping computation, literally layer skipping as an example. We have recent work around how distributed training is hitting some bottlenecks at really large scale, and that there's some hardware limitations that might ultimately be concerning as we continue to scale, and you might have to change the recipe. And we've already seen some of these recipes change a little bit. So a whole bunch of different areas I'm excited about in vision and language and in speech too, and in systems. Yeah.
Wow. You also mentioned that maybe another area that's especially relevant to Southeast Asia is actually AI in voice. And I think especially in this part of the world, there's a lot of software outsourcing and also a lot of call center outsourcing, but also in Southeast Asia, it's quite diverse as a region. So there's so many different languages and dialects as well. Would love to hear what the latest is on for that specific field of research as well.
Yeah. So one of the things I was really lucky to work on when I started out at FAIR was speech recognition. And this was at the time when we didn't yet have end-to-end, truly end-to-end recipes for doing speech transcription. So taking an audio and outputting text. And there were still classical methods that were involved. There was some handcrafting of audio. And this makes these pipelines a bit more brittle, but it also means that it's harder to build models that are very general. Neural networks are so good at generalizing if you give them a lot of data. But if you have handcrafting, it's difficult to handcraft for every little different type of piece of data you have. And so in this case, that diversity of data, those different distributions from which we're drawing audio, is around not only language, but accent and dialect as well. And so in a region like Southeast Asia, which has many languages, of course, but also a lot of different regional dialects and regional accents, it's hard to build robust speech recognition systems. And so we worked a lot on end-to-end systems with only neural networks to do this. We scaled up data a whole bunch, in English at least, to start with lots of audiobooks in order to build a set of audio for English that could facilitate learning without supervision, without labels. And we realized also in doing this work that not every language has a collection of millions of hours of audiobooks, but almost every language has a radio station. And so if I can collect unlabeled audio and learn from that, I can now build models which are far more accessible.
And this also applies to different dialects, different regions, and that scales as well?
Absolutely, right? Because there's almost always going to be someone speaking in the language on the internet, or someone speaking in the dialect on the internet, or with an accent somewhere. And if I can get that data, and I have a model which knows a lot about speech, I can now fine-tune it without labels, without having to transcribe it, and build a model that now works for a new population. And so A bunch of my colleagues at FAIR did incredible work outputting data sets that contain long tail languages, dialects, and accents that include a bunch of different combinations of speech that aren't in existing data sets. Yeah. And this has empowered people to build models which serve hundreds of millions or billions even of people that were underserved by speech recognition systems before. And so that's work I'm particularly proud of coming from FAIR. That it's very fulfilling to know that, yeah, in a region like this, we can enable these technologies that improve people's lives and also enable exciting product applications in call centers or in other voice settings in industry.
That's interesting. I guess when you play around with these AI voice models, a lot of the times, if you do, speech to speech or text to speech, a lot of the voice sounds quite robotic and very unemotional, and people can tell that it's AI when they talk. Do you think that as a problem is going to be solved soon, or what's kind of the latest research or update on that problem?
Yeah, this is a hard problem.
Yeah.
It's hard because speech is a very continuous signal, and the ways that speech differs from human to human are really very detailed. It's not so structured and discrete like is language, where I have a particular token or a particular word. Yeah. It's very continuous. Every little thing changes how the output speech is perceived by people. And so in order to build a system that can do this, I need a lot of data. A lot of data, and I also need a model that scales really well with that data. And for speech is lagging behind vision and language in some respects, in that we haven't really built huge speech models which work really, really well for speech generation. We're getting better, but we're behind where we are in other domains for the most part. And this will catch up. There's research that has to happen in terms of how to scale data. There's research that has to happen in terms of the right model architecture and the right setup to make speech generation really high quality. But we're getting there, and I think we'll get there. The quality of these systems will improve in the next few years.
That's great. That's great. I'm curious, if we zoom out a little bit more and think about, a lot of these systems and this research is progressing very, very fast, especially recently. What does the world look like in the next 5 years or 10 years if you're optimistic, right? Both in terms of what the AI research looks like, but also in regards to how a normal person would interact with the world. What is that vision that you have that you would see?
So acknowledging that I'm not a person building an AI product in this moment, I think a few things will be different. First, we're hopefully going to have systems that can do human tasks at very small scale computationally and with very low latency. That means we're going to have smaller models that fit on devices that can operate in cameras or embedded sensors is the hope. And once we have those things, we can really start to build very holistic systems that are integrated with our lives. One of the problems is that if I want to build a system that operates in my home, I need to send lots of data to the cloud to do inference, and that's not a big deal per se, but if every home in a continent wants to use that system, it requires a lot of compute. And if we can embed these things and do them on device, we can start to enable more applications. So that's one thing we'll see. And that will start to make possible a bunch of the things we'd hoped we'd have from AI, right? That'll enable assistants that are closer to us, or at least systems that can recognize problems, and that'll be exciting. In terms of solving problems and doing reasoning, that's a bit different. It's a bit harder to predict the trajectory of this. My view is that we're going to hit a wall with large language models, and that we're starting to see this already, where performance is not really improving as we continue to scale up data and model size, and we need to rethink the recipe a bit. That will take some time to do. We're going to have to invent new algorithms. The hardware needs for those algorithms might be different because they might involve more structure or more discrete computation in ways that don't necessarily lend themselves as well to GPUs. We'll do our best to use GPUs because GPUs are great for lots of reasons when we're dealing with dense data. But it's unclear what those will look like. And we have some ideas, but this is very blue sky research. And we have to be prepared for that to take some time and for it to be necessary as we start to see some limitations, some cracks forming in the current LLM paradigm. So my hope is that in 5 years we'll have moved forward with this and we can really have models that have never seen a problem before and are able to reason. True world models where they can solve problems that are very real. So that's where I hope things will be.
I guess I'm curious, in light of that kind of future projection, would you still teach your kids how to code? Would you still teach your kids like a foreign language? Like, yeah, how do you think about, you know, inoculating yourself against the developments of AI in the future?
So, personally, I think in the best case scenario, AI provides superhuman capabilities that make life better and easier, and that allow us to spend more time doing the things we really enjoy. Learning a language is wonderful for many people, and so absolutely we should study language. It changes our worldview. It allows us to perceive new things. It's incredible. That said, the need for learning a language might change over time as we build better and better translation systems for speech, for text, etc. But I still think we should focus on the tasks that humans don't like doing, replacing humans in those tasks where we don't need to do those annoying things, and simultaneously making humans more productive. So this is the superhuman idea that I can now just do in 1 hour what I used to be able to do in 10.
Right.
So when it comes to teaching your kids how to code, another great question in that, do I need to know technical things that a model might make obsolete? So my argument is that largely that might not be as important. At the same time, if you're someone who wants to get into AI or do research, understanding these systems is going to make you really, really powerful. It's going to make you into someone who can innovate at all levels of the stack. If you understand how a GPU works and how that's important for parallel computation and how tensor math works and how all these things compose to build a modern neural architecture, then you can innovate in that area. You can choose any of those things. You can co-design the algorithms you build with the hardware that they run on. And so always having that technical depth is great if you're working in this field. If you're working in another field, if you're doing pure software engineering, again, knowing how systems work will make you a better software engineer, even if you're not going to be using those systems all the time. And ultimately, until we build really good world models for code, which we'll hopefully do, but it's going to take time, until we have those, humans are always going to be better at thinking holistically about the systems they're building, and models are going to augment them to make them more productive.
Okay. Good advice. So still relevant for now.
Still learn all the technical stuff because
Right.
it will make you better at doing whatever it is you want to do.
Okay. I guess zooming out, one of the things that you mentioned before was as you collect more data, the models will be better. Obviously now there are some constraints where maybe it's a flattening out of, the marginal utility is not as high as before. That being said, when we look at kind of where various countries and companies or AI labs are headed, these institutions, especially these bigger institutions, are spending billions and billions of dollars building out data centers and hiring a lot of these AI researchers. And it does look like right now that the U.S. and China have a technical lead in some of these model development, right, in terms of AI. I'm just curious, like, if you kind of speculate out as well, like, where does that leave, the rest of the world, right? Is there going to be an opportunity for people to catch up? Is there going to be utility in, working in AI in other countries? And how does that actually, translate into geopolitics in the future?
Yeah. This is a big question. So a few things that are important to remember here. First is that we are seeing some early signs of limitations for scale with the current recipe. And it's possible that we won't need nearly as much scale in order to achieve the results we have previously, and that we may be able to get away with fewer GPUs, networking hardware that isn't as fancy. We'll develop new algorithms to train models, and maybe we'll just need less. That's possible. And I think it's likely as we start to run up against some difficult constraints. But the other piece of this is that countries and institutions and organizations should play to their strengths, right? If you're a country or a company that doesn't have the capital to build a huge data center or to build 10 huge data centers, then you shouldn't do that. And what we hope will happen is that because this field is still very open, we want to stand on the shoulders of giants. We want to release the research we do. We want to release the models when we can. We want to release the code when possible in the open source environment. If we can continue to do that, then that will level the playing field and allow people to participate in this research process. And it depends what the motivation is. For a company that wants to protect its technology, there are perverse incentives to release. But this is really important, and there's a lot of arguments to be made that releasing these artifacts is ultimately just better. It's better for the world in that it makes models more safe. It's better for the world in that it allows people to accelerate research and accelerate progress in the field because they all have a starting point that's more advanced. And it also enables lots of new product applications, right? We now have the ability to build all sorts of things on top of the models that we release. And so if you're doing research and you don't have the capital to build a big data center, don't do that. But if you're building a product and you're not in a place with lots of resources, depend and lean on those open source technologies. That is what you're going to do, and that's what you're going to use to build your thing. And that trend looks to continue. There's a lot of excitement in open source. There's a lot of companies that are getting funded that are all around releasing models, making it possible for people to use models, or at least even if the models are closed, being able to provide APIs for builders to do things. So in that sense, people everywhere are empowered, and hopefully this trend continues and that people continue making models open.
Interesting. I guess even if you don't run into kind of the model constraints limitation, there are still going to be physical kind of energy constraints or those kind of things that countries might face. I guess the more relevant question is, a lot of our audience is from Southeast Asia, and notably in a country like Vietnam or in Southeast Asia, a lot of the macroeconomic development traditionally has been in terms of low-skill manufacturing or factories. And in the age of AI and robotics, whereby if we do see this very optimistic future where a lot of these core developmental functions could be mechanized using AI, and how does that leave a country to actually develop whereby maybe they can't actually do this upfront investment in AI infrastructure or data centers? How do you see that playing out?
Sure. So first, it's important to note that ultimately the supply chain around building data centers is already pretty consolidated. There's a few players which control most of the power in terms of the ability to produce hardware and then have that hardware supply chain generate revenue. And so ultimately building a data center doesn't really provide lots and lots of jobs, depending on the setup, right? These are big buildings that operate pretty autonomously, and they're great for communities, right? Building them is awesome, and they need to be staffed, and so they're good for economies. But the scale at which we're going to build data centers isn't going to fundamentally change the questions facing communities around the world, right? There are going to be lots of data centers, but they're not going to totally change the economic landscape. And the supply chain, again, is relatively consolidated in that there are a few silicon makers, there are a few hardware OEMs that distribute this stuff, and the components of these things are manufactured and controlled by a relatively small set of companies. So in that sense, the expansion of the data center GPU and the networking hardware around it and storage and cooling and all of these things isn't on its own a huge economic boon just because there are entrenched players that have a big advantage and a big head start. That said, the ability to build on AI applications at the other end of this entire pipeline is what will give people opportunities. And again, play to your strengths.
Right.
Use AI as a tool. Think about a product problem you want to solve and use AI. It's really, really difficult to build a better model. It's really, really difficult to serve that model better than a big company that has the ability to invest in really deep technical ideas around compilers or GPU programming or distributed computation. All these things are tough, and play to your strengths. Again, think about the applications of AI that are exciting, or if you have an existing product, focus on that. And that's going to be a better recipe for you in the long run. Pay attention to new capabilities and think about what you can do with your limited compute. You can take a model, maybe you can fine-tune it on device. Consumer hardware is getting really, really good. Apple Silicon is phenomenal, for instance, to fine-tune models or do inference locally. And so there's new possibilities for playing with these models and proving out points. And once you do that, you can make larger and larger investments as you see fit. But focus on validation at small scale. And again, don't try to scale up if it's not your strength, because there are big companies that are going to outscale you every time, and they will scoop what you're doing in all likelihood. And so focus on the product story, focus on building a moat, focus on technical differentiation that's outside of core AI components, unless you're able to do that yourself at low cost. But just be wary of differentiating yourself just because you're using AI. Make your pitch about a product that's awesome and exciting and already differentiated that is supercharged by an AI application.
Are there any specific examples that you're excited by?
Specific examples of AI startups that are doing this. Let's see. To be honest, I think AI startups need to do this better. There are some examples, but I worry a little bit about the moat that a lot of companies in this area are building for themselves. There are companies that are using AI in clever ways. A lot of those are big players.
Yeah.
For example, Microsoft integrating AI into every Office application is going to be powerful because they already have an entrenched base. Take a company like Grammarly, for instance, which has a Chrome extension-based setup where it gives suggestions on writing. That's an exciting foundation. The question is, can you use your existing user base, existing product market fit to improve those capabilities with AI? The answer is yes, so you need to prioritize that. But again, don't focus on trying to build a new model because it's really tough. Unless you have a lot of money, a lot of capital to spend, it's going to be pretty much insurmountable to beat big players. Big players are going to be the best at integrating models into their existing product ecosystems.
So the important thing is to have a product with distribution and also a competitive advantage, and whereby AI would kind of turbocharge your value add to your consumers.
Yeah, and there are clever ways to use AI, right? There are clever ways to prompt models, to get models to output really interesting, specific ideas, like Reforge Labs here in Vietnam is an example. If you can parameterize a storyboard for a video in a special way, or prompt a model to produce a screenplay, and do that really, really well and build a good product story around it, then you can build something specialized, even though the model isn't special. So a lot of that is tweaking how you interact with models and building a product around that. That's viable. But make sure that you have something really special. Make sure that what you've done is something that you feel like you tried really hard and it's not obvious, because everybody is playing with these models. And so make sure that you have a real differentiated approach, and from there, just go build.
I think that's great advice for startups and people alike, right? In terms of how you think about evolving your product and yourself in the age of AI. I think for us, the last section that we like to do is this rapid fire Q&A, which are just 5 really fun random questions that we like to ask every single guest.
Yeah.
So the first question for you is, what is your favorite tech tool or program that you use very often?
My favorite tech tool, this is going to be hilarious, is probably Emacs, the editor.
Oh, wow.
Because the idea that I can use a functional language to program an editor is incredibly powerful, and it enables amazing things. And it's just this old, supercharged tool that does amazing things for you. And it's this dinosaur, and it's a great idea from so long ago. And I use it every day for things nobody has any business using Emacs for.
Wow.
But it's such a hacker ethos, and I really love it.
It's amazing. If you were not doing what you're doing now, what do you think you'd be doing?
I'd probably be investing. And I'm lucky to do a bit of that now, but I'd probably be trying to build companies with people and making bets as to who might succeed and thinking about exciting products, and doing deep technical work with founders. I love doing that. I love finding ways to solve really hard problems with a really clever technical solution. So something like that, just really close advising and investing with individuals and founders.
That's great. What are you most grateful for?
What am I most grateful for? I'm most grateful for how I really have chased the things that I've loved and how I've learned in my life, and how those have naturally evolved to be really useful and powerful and fun. And when people ask me what they should learn about to get into AI or to get into music or to get into teaching, whatever it is, I always tell them to just do what's fun, and everything else will fall into place, because when you're having that much fun and you're that passionate about something, it's easy to be really good at it because you're addicted to it. And so I feel very grateful that the things I've done have landed me in a position where I can do what I love every day.
What's the worst advice that you've ever received?
The worst advice I've ever received. Let's see. Someone once told me that when working with people, that you should temper your negative feedback for them in a way that still ensures that they like you, that you should always be good cop, and that it's never worth being bad cop. And this obviates the idea that people grow and are grateful for feedback you give them that's around improvement. The right mindset to operate in is to build an environment with the people you collaborate with, both in life and work, everywhere, where constructive feedback and criticism is valued and seen as an act of care. I'm telling you something that you're not doing well because I want you to improve it. And that should be a positive thing. And you shouldn't hold that back. And the way you deliver it is an art form, but never shy away from telling someone about something they can improve on.
Radical candor, right?
Radical candor, absolutely.
That's amazing. And then the last question is, what is the best advice that you've ever received?
The best advice I've ever received is that it's never a bad idea to go deeper in a technical area. Whether that's, and it doesn't have to be related to STEM, it could be in learning an instrument or learning a language or studying history. Depth is always good because it gives you a holism in how you understand something. If you know the provenance of the way things are in whatever your domain is, you can see the picture of it all much more clearly. You don't need to guess. You can have a solid foundation for your understanding, and you can see the future in certain ways. If you know the limitations that are about to come up, or if you know the evolution of something over time in the past, you can predict the future that much better. So don't shy away from being deeply technical, and embrace that as a way of making you a better practitioner in whatever you're doing, even if it's not directly related.
Jacob, I think that's great advice, and I think a lot of the viewers on the show who are CTOs or engineers would deeply resonate with that as well. And with that, thank you so much for your time. This has been an amazing another episode of the CTO Show by Tech Vibe. We really, really appreciate you having here, Jacob, and sounds like you love Vietnam, so we look forward to having you back more often. So thank you so much, and see you guys next week.
Thanks for having me, Philip.